Now the next topic is presentational and container components. Okay, so as you all know that we have certain types of component. The presentational and container components was the pattern like originally proposed by Dana Promov, and it is basically deals with a approach, the data down and action up. The data must be passed down to the child components, and the action from the child component must be listened by the parent components. So earlier we used to have like earlier what nowadays we also have this state management library called Flux, which have the concept of multiple stores. So later on, there was the article released by Facebook where they have implemented their own way of using plugs. Then after that, Redux came in, which provide the concept of using single store. Also, the benefit of using single store is that we can share the data across multiple components. And if other stores also want to communicate between each other, we can have that shared data in one single place, and other stores can communicate, can share that data from that store. So basically, in the Redux or other state management libraries follow this principle of presentational and container components. Now, the presentational component is a component which deals with the data part. It has nothing to do with the UI part, and the container components are the components which deals only with the UI representation. The data which you will pass to the container component, it will accept the data and it will render the data on the screen. It has nothing to do with like from where the data is coming or who is sending that data, which, is the component performing some side effects. It has nothing to do with it. So let's take an example. Here we have a clock component. Here we are using a class based component. Here we are using a class component, and we in the state we are just uh, setting the time as the initial time, this dot prop dot time. And in the update method, basically we are setting an interval of 1 second so that it can behave like a normal clock. In the component date mount, the component date mount will call as soon as the component is like rendered on the screen. So it will just set the interval and it will bind this update method of every 1 second. So this update method will be called every 1 second. So what update method does is it simply change the state, set the time key as new date, this state dot time dot get time. So basically, it assigns a new value to the time every second. So in the UI, it will seems like it is just behaving like a normal clock. Now, in this clock, here we are just rendering this clock, and how the render is performed. The render is performed in here return function. It has a simple h1 tag where we have hours, minutes, and seconds. Now, from where this hours, minutes, and seconds are coming is this format time function. Sorry, the format time function. We have simply we have destructured this again. So time dot get hour, time dot get minute, and time dot get second. These are the functions which are provided by JavaScript out of the box, so that we can have that. And also, if the number is below 10, it will append a 0, and it will render it on the screen. Now the main problem is here we are doing a lot of stuff. First of all, this format time function, it basically checks whether the first of all it extracts the time which is to be displayed on the screen, and also it checks whether that time is in a single digit. It like appends a 0 before it. Now if you are a little bit aware about the solid principle of agile development, DAS stands for single responsibility. The class or a function should always have a single responsibility, but here the format time is performing two tasks. First, it uh, extracts the time, and also secondly, it checks whether it formats it into the displayable format. So now, how to avoid these problems? So always the first problem is the clock component mutates the state itself. If other part of the application depends upon this data, it will difficult to share it. So what it says is we have this local state managed here, which is mutated inside from within the component. Now, if other parts of the component also depends upon this time, then it will be very hard to share this time with other parts of the component. And second, the format time is actually doing two things. It extracts the needed information from the data and makes sure that the values are always presented in 2 digits. Now, how to overcome this problem? Uh, to overcome this problem, we have to break this component into two different components, the presentational and the container components. So, here is an example of the presentational components. So, in the presentational components, we are just passing a prop, and in that prop, we are just passing the hours, minutes, and seconds, which are needs to be displayed. And, and secondly, it just maps the data like it makes it into the 2 digits and displays it on the screen. It has nothing to do with like updating the time or extracting the information from the data object. The main purpose of this clock component is to display the data on the screen in a presentable way. Now, if other components of our application depends upon that clock component, the parent clock component, they can now share the data across this. The parent clock component now share the data across other components as well, because it only performs the management of the data. It has nothing to do with the UI part. Hope it makes sense. Uh, do anyone have any confusion regarding this?
No, it is clear.
If I have to give you an example, for example, let's take an example of the Udemy site. Is Udemy site visible on my screen?
Yes, Namesh.
Yes.
So, for example, let's go to the home. Now you can see that here are lots of cards which are like displayed everywhere on the screen. So these are basically the presentational components. The data is just part into the card, the title, the ratings, the price, and the like discounted price. So the main purpose of this card is to like show the data on the screen. It has nothing to do with from where the data is coming, who is passing that data, and which function is calling the API. The main purpose of this card is to like show the data on the screen. And the container component which wraps which wraps all of this information is the container component. Basically, it deals with the API calls, it deals with the transforming of the data, and it passes that data to the child component, and the child component renders that data. Hope it makes sense now. Is anyone having confusion?
No, Nimesh.
Okay, sure. Now, the next part is child enhancing components. Now, what child enhancing it is little bit of advanced topic. So these child enhancing components are the type of component which takes their children component and adds some extra functionality on top of it. So let's move on to another demo. Now, is my editor visible to you?
Yes.
Yes, sir.
Okay, cool. So this is a child enhancing component. So it is simply a wizard component which takes a lot of steps in it. So let's run this and see it in action that what this component is doing. So as you can see that, is my screen visible to you all, localhost 3000?
Yes, it is visible.
Now, suppose we have a lot of scenarios where we want to implement certain steps in our application. For example, step number one, then we click on the next step, it moves to the next step, then so on and so forth. So it is a small demo which depicts the same. For example, if we click the next step, the step 2 is visible. And if we click on the next step, the step 3 is visible. So it is just like a stepper component. So if you see the logic behind this, it is simply a wizard component which holds multiple steps. Now, from where the logic is coming, like if we have to click that button and then the next step will be shown. So let's have a look at this code. We have this step component. And inside that step component, we are just simply rendering the profs.children. And the profs.children is simply this data. This is step one. and we have that button which says next step, and on click of that button we are calling the on complete function which is passed as the prop to this step component. So this is basically this same button. So step component is clear to everyone that what it is doing. It is simple. Should I move forward to the wizard component now?
Yes.
Yes.
Now wizard component is a little bit tricky. It is doing for example, here in the wizard component, you can see that we have passed this steps component as a children. So in the children, we are again using the object destructuring syntax, and we are extracting the children prop, and we are setting the initial step as 0. Initially, we'll be at step 0. Now, we are just using this method react.children.toArray. Now this what this method does is just it takes the array of the children and transforms it into a array of react elements. So now here we will be having the array which will contain all these steps component. If you want more step components, yeah, you can append those step components here, and it will pass to this array. And we have just changed the reduce function. Now, if you're familiar a little bit with the reduce function, what it does is it takes a callback function, and the second argument is the initial value. So we are passing the initial value as an empty array, and in the callback function, first we will receive that value, the array, then we will receive the each child element and the index. So now it checks whether the index is greater than step. Now, if the step of that index component is greater, it will do nothing. It will just simply render that initial array or the transformed array. Or if the index is less than the step, then what it will do is it will create a new array. It will spread the original array, and then it will call this component, this method react.clone element. Now the react.clone element, what it does is it simply takes a component as an input and adds some extra properties to that input. So as you can see that we have defined on complete nowhere in this step component, so we are passing it from here. So on complete is passed as a prop. Its value is a function which will simply set the step as index plus 1. So if now whenever the next button is clicked, next step button is clicked, it will just mutate this state, and it will change the value of this state. So the UI will be re-rendered again, and the extra set of steps will be rendered on the screen. Now, if you are having a little bit doubt or confusion regarding this component, certainly this is the code which we will never write in our production grade application. It is basically the code which is related to the frameworks. You will find this type of code in the frameworks or in the libraries. You will never write this code in the production grade application. You can build a library, and what those library will do, those library will simply extract expose these components which you can use in your application. Now, child enhancing component has nothing to do with like what logic is performed behind the scenes, what wizard component is doing, how the functions are called when next button is clicked. So this is basically a child enhancing components. Basically, the wizard component is enhancing its children by passing some extra functionalities to it. Hope this makes sense now. It is a little bit of an advanced topic. You will never write this code in the daily production grade application, as I have told earlier. It is a framework level code only. So, do you have any doubt regarding this?
No, Namish. This is clear, but can you give a one more example for where we can use this apart from stepper components?
Yeah, basically, obviously, and it is basically we can use it inside the tabs as well, where we have certain tabs. For example, if I can see in the Udemy, I don't know. Yeah, basically, whenever we switch those tab content below that tab is switched, so you can have that tab as a children prop to some parent component, and it will just the parent component will simply check that which tab is currently active. It will show the content related to that tab and hide the rest of the content. So yeah, there are multiple use cases where can use that. But this, as I have told you, that you will find this type of code already cooked up. You don't have to write again and again. So that's the benefit of using some libraries. It saves us a lot of time because someone has already implemented something and you are just using their APIs to like achieve something.
Okay, understood.
Okay. Basically, the main function here was clone element. The whole clone element returns a new element using the element. The resulting element will have the original elements prop. So, and it will have the new props which we have passed. So here, the step component will already have the original props which are passed to it, and also it will have this extra pop which we have passed here. So this is the main part of this enhancing component. The next is the child aware component. Now it is also a little bit of a library based component. Now, how many of you have heard or used this library, Victory Charts? Is anyone here who have used this library?
I have heard about this, but I know whenever I have to make some charts in my UI, I normally go with charts.js.
Yeah.
But I have seen this one. I have seen this one in past.
Yeah. So basically, Victory Chart is a great library for like designing the SVG charts. We have other libraries as well, like D3JS or Charts.js, but Victory Charts is a library which is totally built on the top of React. So it provides a huge performance benefits as compared to other libraries. You can definitely have a look. It's a very great library and have a less learning curve as compared to D3. So here you can see that we have a simple chart, y-axis and x-axis, and here we have this line. And the code for this chart is very simple. It says a victory chart and a victory line. So victory line simply accepts a data prop, a sample data. So that sample data is enough to render this line as an SVG. But have you ever wondered that where this information is provided to the component? Like the maximum limit on the y-axis will be 7, the maximum limit on the x-axis will be 7, what will be the interval? You can see that there is no such information provided to the victory charts. So what interpretation we can drive is like here is a bidirectional communication, like the child components are communicating back to their parent components. Now earlier when I was discussing about presentational and container components, we have this term called data down and action up. Now here it seems like it is a little bit conflicting with that approach, because here the victory line is somehow communicating with the victory chart component, which is its parent component. But if you will like inspect a library a little bit, it turns out that victory component is interrogating with its child component, because each child component exposes its data via prop or a selector and is passed through a parent component. What it says is basically victory child always can interpret the data which is passed to its child component, and on interpreting that data it can similarly determine that how the external part of the graph should be drawn, like what should be the maximum limit on the y-axis, what should be the maximum limit on the x-axis, what intervals should we follow. So if you will have a deep look inside the victory chart, you will see that there is no bidirectional communication. It is the only that victory chart is only communicating with the victory line component. So this is basically what is child aware component is. So it turns out that the victory chart component is interrogating with its child component. Each child component exposes its data via prop and a selector and is passed through a parent component. So yeah, so basically this is what the child aware component is. It is basically aware about what data is passed to the children component, and it basically renders the parent component based on the data. So also this is basically a little bit of library dependent code. You will not find, like, it will be a little bit hard for us to write and maintain this code in the production grade application. That's why it is always recommended to write such type of code in some library and use that library in your code. So do you have any confusion regarding this? Because it is a little bit of advanced topic.
If anybody has any doubt about this, they can also share their questions in the chat section.
Yeah, basically that's it from my side. If you have any questions regarding the session, please ask in the chat, or you can ask by unmuting your mic as well.
Apart from victory charts, can we see an example of child-aware components?
Yeah, basically there are lots of examples. You can see various libraries which perform such type of stuffs where you don't need to provide some extra information. There are certain libraries which extract the information from the child components and renders the UI based on that information. So basically, libraries are designed in such a way just to ease our task. If we have to write the code on our own, then what's the benefit of using the library? So, as I have told earlier, that it's basically a library dependent concept. So, library or framework dependent concept. These types of code will generally not be written on the production grade application because these are hard to maintain, and obviously if you are passing this code to someone else, you have to write a thorough documentation that how this code is performing and what the actual use case of behind writing these codes. So there are certain examples like D3 also uses this same concept. The victory chart is using it to interrogate with its child component and re-renders renders the UI based on the child component.
Understood, Navesh.
Yeah, sure. Yeah, I'll be sharing the slide to you along with the GitHub link of the code, so you can have a quick reference from there as well. So if you have any kind of